Just a brief introduction. Thank you guys so much for making it out here. Thank you for being a part of the CDCA internship program. Thank you to the sponsors for going out there and looking for these great interns and applying and trying to be a part of this. And thank you, interns, for taking that next step into hopefully coming into our industry or getting that next step into getting a job after you guys graduate. A little bit about myself. I'm the CDCA Education Committee Chair. Back in 06, I believe it was 06, I was where you were. I was an intern with a company here locally. Parlayed that a couple years after I graduated into a full-time position, and I've been with the same company ever since. One of our speakers today will kind of have a similar tale, but just a little bit about myself. That's where I came from. I've done exactly what you guys did, and now I'm here presenting to you guys, having all sorts of IT problems and dealing with fun stuff like that. So without any further delay, I'm going to jump in and let Ken and Amy kind of jump into that first icebreaker for you guys, and then we'll get started with the rest of the fun stuff to that. Dr. Mondi works for SPAWAR. He's the lead for science and technology, as well as the discovery and invention business portfolio manager. He's responsible for ensuring the center is appropriately positioned to perform research and deliver the next generation technologies to the warfighter. Dr. Mondi has PhD research in the field of neuroscience with focus on neuronal processing within the mammalian visual system. He received a master's degree in electrical engineering and his PhD in neuroscience from Syracuse University. Now he's down here working with SPAWAR Atlantic in the areas that I discussed. So without any further delay, I'll let you get up here and make people even smarter. Thank you.
So it's been said that I kind of have one of the coolest jobs at SPAWAR, and actually I think I agree. I'm the CTO there, and for those that have kind of followed SPAWAR for a while and the pedigree, we haven't typically done research in our history. We came from the shipyard. We did a lot of installations on ships and maintaining systems, logistics kind of stuff, long lead time. But we are a Navy lab. And one of the problems was that we weren't really recognized as a Navy lab within the Navy organization. So it was kind of my job to change that. And so I got here. I was at the Air Force Research Lab for about 14 years, and then came down here after I got my degree. And then my job since then is basically trying to put SPAWAR on the map from an S&T perspective. And we really got started, even though I was here in 2000,
Right.
we really got, can you find it?
It's an older version, so this one won't
Here,
play.
just plug in this one.
But yeah, I can plug yours in. Gig technology. Hopefully you interns can solve these problems.
2006 is when we really got started, and I started hiring a lot of folks into SPAWAR that really had advanced degrees. So for the most part, when I'm standing up my S&T organization, mostly I have master's and PhD level folks working directly for me. Because if I'm standing up an S&T capability, I want the strongest degrees I possibly can get on the front edge of that. So these are people that are used to publishing, people that write the peer-reviewed journals, are recognized and publish them there, go to conferences, and so on. So when you think about C4ISR, there's many different Navy labs, and we all do a little bit something different. SPAWAR does really what we call information dominance, and that's C4ISR. So I'm sure everybody's kind of familiar with that. So hit that once. So if you think about this kind of a constellation where you have ships talking to airborne platforms, to ground platforms, you have sensors out there and so on, it kind of gives some sort of a feeling of what we mean by command and control communications. All of this needs to talk together. They need to be able to work together, and you use computers in order to do that. And also we have a lot of intelligence going on, people collecting data, a lot of surveillance happening, and a lot of reconnaissance. So that's the C4ISR kind of world that we live in within SPAWAR. We don't build these ships, we don't build the platform so much, but we do pretty much touch everything that has to do with information technology, or what we consider information dominance. So my job is to say, okay, if this is what our mission is, what are the things or what are the emerging technologies that are happening in order for us to do this better, right? So from my perspective, I have to peel the onion back at least once more. And that then starts saying, okay, well, I need some advanced communications capability, I need better networks, I need better analytics. This is a big thing for us here recently. Data handling, how do you handle all this data? It's got to be mobile. I have a really stressful computing situations. How do I present this data to the man-machine interface? And then ultimately, you heard about all the drones. Now I have all these autonomous systems out there. So these are the areas, when I see C4ISR, These are the key words in white that I actually begin to see from the CTO perspective. So now we start taking investments and trying to figure out how do we invest in these areas, and what skill sets do I need, what kind of laboratories do I have to have, and how do I build this capability at the organization. So next slide. So this is, think about advanced communications. We're going to delve into each one of these words in white. So advanced comms, this is a shot of one of our anechoic chambers. Anybody familiar with what an anechoic chamber is? Okay, so what about the interns? Not so much. So anechoic chambers are basically, when you walk into like a studio, if you're going to record something in a studio, you walk into like this dead space and they got this sound stuff on the wall. This is very, very similar, but only an RF space. So if you have an antenna and you're transmitting, these cones are actually tuned to certain frequencies, so it absorbs all those frequencies. So you don't have all this bouncing going around, you don't have all this multipath happening. So if you want to do research and you want to look at advanced communication systems, you need some sort of a capability to do that, some sort of lab infrastructure. This is one of the things that we've invested in here recently, are state-of-the-art anechoic chambers, so we can actually test some of our products. So when I look at emerging technologies, again, my job is to try and be like the weather forecaster for technology. So when I look at advanced comms, what's happening over the next, maybe say 3 to 5 years? Our laboratory isn't a lab like academia where you're working on things maybe 10 years out, maybe 15 years out before it becomes a product. We're looking at things a little bit more near term. So driven by the use of unmanned systems, basically we're beginning to predict that the data links that are required, so if you have a drone and you have all these sensors on the drone, and all that information has to come back to some command and control point back on land, you've got to have very, very strong data link capability, you have to have very wide bandwidth. And these stressors, now you've heard that everybody's using drones, everybody's using autonomous systems, that's not going to go away. And as you'll see later on in the brief, we predict that the last fighter pilot's already been born, right? So everybody else is going to be basically joystick. So at this stage of the game, we're trying to figure out what do we need to invest in, and we're looking for folks that have capabilities in these areas, basically. This is where we think we're driving the command. So bandwidth efficiency, LPI, which is low probability of intercept, ways to communicate from that drone without anybody else know that you're communicating. We also think that using the spectrum usage, there's a lot of RF spectrum out there that's not being used. People have license for it, so they block it, but when you look at the spectrum at any given time, there's very few frequencies that are being used at any given time. So the military thinks, well, if we know that, and so does the commercial world, frankly, if you know what frequencies are out there, even though they may be licensed, can you come up with license agreements so that I can use that frequency space? And that knowledge has to be put into some artificial intelligence engine within your communication system in order to realize that capability. And the other interesting thing that's happening is the wired networks are becoming, wireless networks are becoming much, much, much faster. And so wired networks have always been fast. That's not anything surprising. And then you have the fiber optic stuff, and that's even going to be faster. But what's interesting is the wireless networks are catching up. And what's always been the problem is when you have one system running faster than another system, the way you interface that is through a buffer of some sort. So the buffers have always been a problem. When you're coming from wireless onto wired onto wireless, you slow down significantly. But some of the research happening in Germany now is suggesting that you can download like a DVD in a second over some of these wireless systems that are out there, and they're operating up in the 240 gigahertz range, something crazy. So we believe that these two worlds are becoming together, and we're going to see many, many changes in our network systems because of this off-ramp and on-ramp capability that we haven't really seen in the past. So these are areas that we're beginning to invest in, beginning to grow in the organization, and partnerships that we're actually trying to set up with our industry and academia. I sit on the USC's Industry Advisory Board on their engineering department, and one of the things that we talk about on a regular basis is who are we hiring into the organization, and do they have the skill sets that we need? And if not, the college is motivated to change their academic program in order to make sure that you guys have the right skill sets, so that industry is going to be hiring you, right? So they're looking for the best student they possibly can produce, and industry is out there trying to tell them, here's the skill sets that we're looking for. So this kind of brief is what I've been giving to a lot of the universities around here as well, to let them know when we hire into SPAWAR, these are the skill sets that would be great to see on a resume. Thanks. Networks is another issue. This is a shot of our one of our data centers, one of our cloud computing centers that we've got actually up on the north basis of Charleston. Next. So when it comes to networks, there's some things that are happening here in the world that we've got our eye on. So homogeneous networks and heterogeneous networks, you have these kind of thin front line. If you think about it in a military perspective, these guys are carrying rifles, they got all this stuff on their back, they're on the front line. We can't pump tons of bandwidth to them. So there's a thin line on the front that's got to come back to more appropriate or more capable networks in the back. How do you connect these networks together in a secure way is an area that we think is rich in research. And Internet of Everything, these sensor-driven networks, the networks now that are being developed are about machines talking to machines. The Internet that we use today is typically geared for the human interacting with the network to get certain data from that network, to use that network in certain ways. Now what we're doing is we're building machines that actually talk to other machines over that network, and the data is going up exponentially. 90% of the data, I think that's been collected so far, has actually happened in the last 2 years, and that's going to go up even worse. So the way you design networks is completely different and will need to be completely different than the way that we've designed networks in the past. Jammer detection, defense, authentication, secure routing protocols, network security, authentication, all of these things we think is very, very great research areas that we need to get into. Next. Analytics, this is one of my employees. This is Dr. Scott Armel. He's a UC Berkeley graduate. We hired him a couple of years ago. He's a physicist and a mathematician. This is kind of his world, living in front of a whiteboard and teaching people about information entropy. What he's looking at is basically how can you decide when you don't know what you're looking at in data and it begins to organize in some way that you don't understand, the entropy drops. So in that situation, if you understand how to look at the entropy, you can begin to understand how data is starting to organize, even if you don't know what the data is. It actually tends to be quite powerful when you're looking at encrypted data or what you think might be encrypted data. And we're actually now applying this to EEGs and brain signals as well. I'll talk a little bit about that in a couple more slides. So some of the things that are in analytics is this problem about trust. A lot of folks are trying to use social networks, digging information out of social networks to make decisions. But the problem is that social networks depends on the context and the situation at the time. And there's a lot of rumors going in social networks. So if you base a decision, in the case of the military, if I've got a drone, where I've got to drop an armament on what I believe may be an Al-Qaeda cell based on something that I'm hearing on Twitter, you better be pretty darn sure that that's good information. And there's rumors that will happen on Twitter, and then it takes you can track this over time. It takes a while for that rumor to be kind of worked out, and people say, no, that's not true, this is really true. No, that's not true, this is really true. Well, depending on when you make your decision, you'll be maybe making your decision on false data or untrustworthy data. So how do you know that? How do you analyze that data? And how do you decide whether it's trustworthy or whether it's not? So here's just basically some of the issues that we think is going on. The other interesting thing is when you look at data, it's based on your question. So if you're trying to get information out of your data, you build all these statistical engines and all these inferences and so on because this is the question that I want to ask. But a lot of times what happens is once you get that data, you say, oh, well, that's not my question, this is my question. And when you do that, all the statistics change. So how do you have these fast-changing statistical engines based on your context of your question? And that becomes to be really quite tough. So we believe that this is a huge area for us. Information dominance at SPAWAR is kind of our home platform. And so from that perspective, we've got to understand information. We have to understand how we can dominate over that information and deliver that information. And analytics is core to this whole thing. So I can't get enough mathematicians and physicists into my staff at this stage of the game. And that's something that would be a prime target for us over the next couple of years. Next. Mobility. This is, again, in one of our labs. The devices here that we're actually working on is something called galvanol. Galvanol is a material that when it's flexed, it actually generates electricity. So the thought is that if you have these mobile devices, you have these sensors on you, you got all this capability, is there a way that I can kind of harness the vibrations or you running through the field or whatever the case might be to help power my systems, to help power my mobile products? This is a joint effort that we've got. This is Peyton came from USC. He's got a master's in battery leveling, and his master's project was in lithium-ion batteries and charging multiple lithium batteries in a bank. And different batteries will charge at different rates. If you're not careful, you burn batteries out, and that's kind of what he was focusing on. So he took his ideas and started applying it to this galvanol research capability. And then this is Dr. Sean Curtis, who's one of my supervisors who oversee the basic applied research at SPAWAR. So when it comes to mobility, there's a lot of stuff that's on our mind here. So high energy, fast charge energy storage devices. There's some universities currently working on these membranes that ions can flow across that membrane very, very quickly. So literally you can charge in, plug into the wall, charge in 2 seconds and leave. Now it may dissipate a little bit quicker as well, but that's okay. If you can find a receptacle somewhere, then you can charge within seconds. So that we think is going to be probably have application of what we're trying to do in Presence technology is interesting. We're all familiar with GPS. But there's gyros in pretty much all of our smartphones and things like that, and they kind of know where you are even though you don't have a GPS signal. That technology is kind of already here. It's being pushed heavily by the commercial world. If you're walking down the mall or walking out here in the street and you happen to walk by a store and the ad that's pushed to your cell phone happens to be for that store that you just walked by, that's something that the commercial world is very, very interested in doing. And they're currently doing that now. But if you're inside a building and you don't have GPS technology, how do you get that signal and how do I know where you are in the mall, for example? So there's a lot of work happening. What we think is going to be the case, though, is that presence technology is really not going to be adopted as much as we would hope it to be, because a lot of people don't want you to know where they all are at all times. So it's not the technology that's going to be preventing that technology from being accepted. It's going to be the social dynamic of it. And that is, I'll let Google know when I want them to know where I'm at and when I don't want them to know where I'm at. The other big skill set that we can't seem to find enough on is programming apps is one thing, but programming the processors that are inside these systems in a very, very efficient way so that you're not draining the batteries too much, and you understand the memory management that has to happen. This is kind of like, very, very low-level programming that happens on the processor itself. These processors are changing all the time. They're constantly being upgraded. And it's very, very hard to find graduates coming out of college with this kind of capability, but it's where the government is going. Embedded system processing, embedded system development is something that we really need to get our hands around. Mobility is here to stay. There's no question about it. As you guys become employees, you're going to demand this, right? That's your world today. And so if we can't give you some sort of a mobile platform to work from, and we can't give our warfighters mobile platforms to work from, then we're going to be at a significant disadvantage. So how to program these platforms in a very efficient way and understand that memory management and the battery and power trade-offs that you need to make is not an easy thing to do. So to find someone coming out of college with a little bit of comms background, with a programming background, and maybe a little bit of cybersecurity background is almost impossible. Each one of those are separate study fields pretty much with a degree in itself. So these are some of the things that we're recommending to the colleges. If you can tweak your program a little bit, offer a course here, offer a course there. Next. Man-machine interfaces. This is something that we're getting into here recently. As Jimmy mentioned, I'm a neuroscientist. That's what I'm trained in. Also in communication systems was my master's. So I kind of have two focus areas that I'm relatively literate in. This is a new system that we bought. It's cutting edge. It's state of the art. It's a 256 electrode EEG. And so here we have a couple of my employees setting up an experiment where we're just basically trying to understand what the EEG signal can give us and actually what area of the brain is it actually coming from. So what we're trying to get into is areas, again, of trust. Trust is an interesting thing. If you have an autonomous system, which is now considered an augmented part of your workspace, if you're a military guy and you're flying this thing around and you're asked to do something with this autonomous system, do you trust it? And even more so, can I put the smarts in the autonomous system to know whether it knows whether I trust it? So it's kind of like a parent-child kind of relationship. You give them a little responsibility, and if it performs, you give them a little bit more responsibility, and that trust begins to grow over time. And we think it's going to be a very similar paradigm for autonomous systems. As these drones become more and more prevalent, we have to be able to talk and understand each other in a completely different way than we've done before. So if I can get access to actually what's happening in the brain and how the brain is thinking about certain things, I think that will push us in quite new areas that we've never been in before. So some of the ideas that we're thinking in man-machine interfaces is next. So hyperspace modality. Right now it's funny because we have never really gotten beyond the keyboard and the mouse. We keep going back to the keyboard and the mouse, and somebody will come up with something new, and we go back to the keyboard and the mouse, and that's just the way it's always been. But we live in an environment where we use all of our senses at all times. So, one of the thoughts that we had is like, well, if I could at least invoke some sort of a three-dimensional auditory capability, and you can imagine, like, if you're listening to, like, you're in a communication, let's say we're in a room like this, and you have multiple conversations that are happening. Your brain is able to adjust its attention, right? So I might be looking at Jimmy, but I know that you're talking over here, and I might be looking at Jimmy, but I'm really listening to that conversation. We do it all the time, right? It's what our brain does. Well, if you're talking on a radio, let's say 5 different channels are happening, and 3 different conversations are happening. If I have some way of listening to those conversations and knowing where those radios are in geographic space, through GPS, let's say, then I can make it sound like this conversation is coming from this area and this conversation is coming from that area just by using all this different type of information. So this is what I mean by a hypermodality interface. We don't do it very well right now, but we are built this way. And I think that we're missing the ball on a lot of things when it comes to information dominance and how to portray this new data and this new knowledge to a man or to a person. How do you do that in a way that makes sense? Wearable devices, it's kind of interesting. You know, part of the reason why keyboard and mouse and stuff really we haven't gotten past that. Google Glass has managed to break a threshold. And a lot of us technologists are watching this thing. It's not so much from the technology, but what's interesting is there's been all kinds of different ideas for user interfaces. You strap things to your hand, you move your hand, you can have kind of grasping control, but it's kludgy, it doesn't look cool. When you're walking down the street, it's not really accepted. Google Glass is, right? People are like, wow, where'd you get that? What do you think about it? And it strikes up conversation. So you pass this elegance test. It's kind of interesting. So for new types of devices and your interoperation with technology, it has to get past this thing, and Google seemed to make that work. Again, like I said, presence technology, we think it's really going to be the privacy concerns that people have that will adopt that technology or not. We'll see where that goes. And then ultimately, if I know whether there's an alarm for emotions or whether you're stressed or whether you're tense, then that will determine how I provide data to you. If I'm overloading you and you can't do your job and I can pick up on that, then I might change the way that I portray the data to you. I might do it a little bit differently, and I might figure out what's working, what's not working for that given person. And so this all has to do with the interesting interfaces and studying the human being. And then lastly, one of the areas that we're looking at next is autonomous systems. And for us, we've kind of increased the definition of autonomous systems. So far from what I've been talking about, it's mainly like drones and so on. But autonomous systems is also Siri, for example, right? That's an autonomous system. My computer, my friend kind of an idea that are autonomous systems. So this is a WASP. This is on the north side of the range, the north side of the base. We have a track. It used to be a test track for the security folks who learned how to drive high-speed chases. But they decided they didn't need the track anymore. It was a 2-mile track, and now we've acquired that track to be part of our flight line for unmanned systems for UAVs. And so we do a lot of work with DARPA. People heard of DARPA, Advanced Research Projects Agency? This is one of the projects through the joint relationships that we have with DARPA that, again, have just been stood up in the last couple of years. We are working with them and helping them develop some of the most cutting-edge unmanned systems that are out there. So we now have the ability to fly this. If you look at the Charleston Airport, it's got the 2 flight lines, and then when you project this over to the base, our area is right in the middle of the 2 flight lines. So we got some capability approved through FAA to allow us to fly some of these things at below 1,500 feet. So now we're beginning to stand up this capability. Next. So when you look at autonomous systems, we have a lot to worry about. One of the problems is that they're so small you can't detect them. So there's a lot of technology that we are starting to look at to try and figure out if you have an unmanned system come into your airspace that's very, very small, but yet it might be carrying something very dangerous. How do you know it's there? So we're looking at what comes off the wings of these things, like the vortex that's created. We're looking at pressure differences in the air. So it's not just a radar pulse, but is there something different that you can think about that might give you some idea that this thing's out there? There was an interesting story. We lost one of these. Normally what happens when you fly them, if you lose radio contact, they're supposed to know to come back. Right? They have a GPS coordinate in them. They come back to that coordinate and they shut off their engines and they fall. Well, we lost contact with one of these and it went up over the trees, never came back. And then our captain gets a phone call from the base security police saying, hey, we found a UAV, a small little micro UAV. Is this yours? Well, she didn't know that she lost this thing, that I never told her. So next thing I know, we have NCIS involved, we've got FBI involved, because they're thinking someone's spying on the base, we got this little micro UAV flying around. And it all could have been prevented if I just would have put a sticker on the side of this thing saying, if found, call me. So now all of our UAVs have that sticker, but calls to the front office to get that lesson learned. But anyway, combining artificial intelligence and all this stuff kind of together is really going to be a big thing. And then, like I said, the last fighter pilot we think has already been born. So it's a completely different way of thinking of things. So I think that's the end of my talk, and I don't know if I've got any time for questions or anything to discuss.
Yeah.
Thoughts or concerns? Or?
Anybody have any questions?
Something interesting I saw the other day, I was reading about how I think the CIA was looking to solve a computer science problem of detecting sarcasm in social media.
Yeah.
So that's kind of what you were talking about.
Yeah.
true and what's not.
What's interesting is we have a couple projects funded in facial recognition. And not just facial recognition to decide who you are just by looking at your facial characteristics, but by raising an eyebrow or the way you might look will tell me whether or not you're being truthful or whether you're not, or what your intent might be at that time when I recognize what's happening. So we thought initially there's not a whole lot there, but the studies are really showing that there probably is. So we've been funding that now for a couple of years, and now we're starting to team with universities and we start up some of that research. NSA is very interested in that. FBI is very interested. CIA is very interested.
Anybody else? Any questions? Yeah, good.
How do you have any kind of summer, it seems like it'd be a great program to have some summer trade programs with different PhDs from maybe some schools to come in. And,
We do.
Yeah.
That was something that when I was up at the Air Force Research Lab, we did that every year. And that summer that the faculty members would come turned out to be the seed of ideas for the rest of the year. And then you just bring them back the next summer and just keep on doing the same thing. We didn't do anything like that at Charleston. So a couple years ago, I stood that up. So this year, and we've been doing this now for a couple of years. This year, I believe we have 22 visitors coming in. I believe over half of them are faculty members from all over. And then we also have what they call Smart Scholars. These are folks that are in college, applied for a government scholarship, got it. And then what happens is they say, hey, I'd like to come work for SPAWAR. SPAWAR looks at their credentials. We basically make a decision, and then they sign a contract, we sign a contract, and they're our employee even though they're still at college. So they come over the summer. And then on top of that, we have the CDAP students and the NREAP students, which are high school kids and then college kids that will come in. So when you look at that whole thing, there's about 22 folks that are involved in that summer research team. They're showing up now. Some of them showed up just a couple of weeks ago, and they'll be here for anywhere between 10 to 12 weeks. And then they're partnered with all my staff to make sure that they're working on, because a lot of the faculty is coming in to do their sabbaticals. And so I got to make sure that they're focused on something that is productive, because that's what they're looking to get out of that relationship. So that's been quite helpful. Yeah.
Anything else?
What was that acronym for the high school program?
CEAP, S-E-A-P, and I'll have to give you what it's called, what the acronym stands for. And then there's NREAP is the other one. Yeah.
I know a lot of agencies, DIA for example, have set up these kind of Netapedias in order to provide a channel for industry and provide innovative ideas to the government. Is that something that SPAWAR may consider doing in the future?
Yeah, I'd have to learn more about it. What we've learned is that a lot of times industry doesn't want to share the idea too much, because they're not so much with the government, but they just want to make sure that nobody else in other industries sees the idea, right? So that's the problem that we've always seemed to run into, to make sure that we can protect the intellectual property, protect the idea in a way that everybody feels comfortable. I know that DTIC has stood up some sites to allow industry to submit their IRAD research to DTIC, and then DTIC guarantees that only government eyes will see it. So even though all industry can submit, industry can't see what other industry is submitting. But we have a big concern with sequestration and the budget's going down. How do we leverage our S&T investment? And we have a very common goal that with industry, and that is as you invest in your own IRAD ideas, you want to make sure that those ideas are on the mark and have a great potential to go into a product. So the more you learn about the government requirement, the better off you would be. Well, the more I teach you about the government requirement, the better off we're going to be. So what we're trying to do is figure out how do we leverage that IRAD investment, which is over $2 billion across the nation, to areas that we think is important for where the DoD needs to go, especially for DoD companies. And so DTIC recently has been pushing this whole idea where companies can come in and submit their ideas through there, and then federal employees can go and take a look at the ideas. But I'm not familiar with the other. Any questions?
All right.
Thank you.
Token of our appreciation from the CDCA for doing this for us, we'll give you one of our challenge coins.
Thank you.
So appreciate it. Thank you so much. And that was Dr. Mondi. Next up, we have Chris Boyd, who, like I mentioned, was a previous CDCA intern in 2011 for life cycle engineering. After graduating from USC, he parlayed that experience into multiple positions with LCE, including software developer, systems integrator, and QA engineer. I think even something newer than that last time I checked your site. But without any other delay, Chris Boyd.
So, good morning. alluded to, was a previous intern at life cycle engineering. I've stayed on with life cycle engineering and within the industry. So today I hope to present some of my experiences to you guys and the interns, and I hope maybe you learn something through what I've gone through. So first of all, congratulations. You guys are positioning yourself very greatly here with an internship. Sometimes they can be hard to come by. You get great hands-on experience, not just some of the theoretical stuff you might learn in school. So it's a great opportunity, and I'm sure you'll learn a lot. Gifts certainly make everything better. So, Carlton doing Carlton. So what I'll be going over today, I'll be going over a little bit about my education, some of my experiences when I was an intern, some of my experiences after an internship, what I ended up doing, and what I'm doing now, and a little bit more what I think about the industry as a whole here in Charleston. So I studied at the University of South Carolina. I got my Bachelor of Science in Computer Engineering in 2011. I think I read you might have one other game called Intern. There you are. Congratulations. The rest of you were not all perfect, so it's fine. So I don't exactly do computer engineering work. I kind of picked that major because I kind of like the whole picture of things. Computer engineering seemed to kind of do electrical engineering, some computer science, and all between kind of stuff. And really gave me a whole picture and kind of left options open what kind of direction I wanted to go in. And who exactly knows what we're going to do when you declare a major anyways. So it worked out great though. And more so in my later years, I kind of went the computer science route and started taking classes like with databases, security, things of that nature. So my internship. A few months before I graduated, I got a call about an internship opportunity with LCE. I thought it would be a great opportunity. At that point, I hadn't had any work experience, so there's kind of that conundrum: you need experience to get a job, you need a job to get experience. So the internship I thought would be a great start to my career, so I accepted that. And I did my internship with Michael Hoyt at Life Cycle Engineering, over there, and it was a great opportunity. I learned a whole lot more than I thought that I would. I remember thinking that I learned so much more in 2 weeks than I would in a semester at school, and it was great because I learned a lot about Linux. I did a lot of operating system type things. It was sort of like a sysadmin type position that I was doing. I used Puppet, which is a technology to kind of auto-deploy and maintain systems. And basically what kind of the project that I kind of had as a whole for the internship was to use Puppet and deploy a certain number of virtual machines and automatically make those machines STIG compliant, which basically means that each system, in this industry would need to follow certain security practices, and that's usually a big manual process that you would type in and set certain folders to different permissions and things like that. But this would do it automatically. And learned a whole lot doing that. Networking, Linux, Puppet, virtual machines as a whole, I hadn't really messed with in college. And of course, with an internship, you're going to have lots of very smart people around you that are doing things like this. And they'll certainly help you and guide you through, kind of like a one-on-one kind of teacher experience as you do this. So it's really great. So that's my internship. Basically, I guess LCE liked me. I very much liked LCE, so I signed on full-time with LCE. Just in time for the student loans to kick in, so that was great. And so my first year, I kind of have a lot of order. Click the next one. Kind of right after the internship, I did some job development, and it was really great experience. It was very different than doing development in school because this is a full project and there's lots of supporting tools within that project that you use that you don't really do when you're just banging out code in school. Like using Subversion repository, Git, using things like that. And so that was a great experience to get up to speed on that kind of things. After that, I moved over into an integrator/sysadmin position, and I actually had a seat at SPAWAR. Some of the projects that we'll contract through would require the person to be on site at SPAWAR. So I set up a lab there, and that was a great experience because there's lots of security things you'll learn, and it's great to be in that in that world, and it was a very different experience. And so certifications. Certifications that I've gotten because also that I've worked at SPAWAR, sometimes to be able to have root access on certain boxes and things of that nature. Certain projects will require different certifications as well. So since my internship, I have gotten a CompTIA Security Plus, basically your general security type certification that you get. And then I also have a CompTIA Linux Plus. So kind of with the Linux route with the operating systems. So obtained that cert. And more recently, I've done a lot of back-end testing. Working on a project with the Air Mobility Command at LCE now, sitting there. And it's my team does a lot of Java Web Services. And so there's a lot of back-end logic testing that I would do. And using SoapUI is the tool to test back-end web services. And with that tool, there's also room for development in there because I wrote a lot of scripts to test things a lot of automatically, a lot of automated testing. So there's a lot of room there to make what I want with it and get as technical as I want with it. And that was a good experience. And so as you can see, I've went from testing to integration, development, a lot of different positions, and it kind of goes with my mantra of liking the whole picture. I like to get my hands on a lot of different things that I can within what I do. So right now, I'm on the same project. I moved from testing to Java service development, and it's been great. I definitely like getting back into development. With LCE, with the industry, there's lots of opportunities to do all kinds of different computing things. And development is certainly one of my favorites. I'm currently studying for being a certified ethical hacker. That might be your reaction. Studying to be a hacker. But it's great. The whole point being is if you can think like a hacker, then you'll know how to prevent hacking. Of course, we all know in the news and the media today that all kinds of systems are being compromised, sensitive information being leaked. So especially in the defense world, information assurance and information security is a very big deal. And to be able to protect that is a big deal. And certainly one could make a very long, healthy career out of information security. And one could also do something called penetration testing with knowing how to hack, which basically with permission of the person who owns the systems, you would attempt to compromise them. And when you do so, you then enable them to help protect the systems after that. So that's certainly very interesting. And I read an article not too long ago that information security is certainly getting high demand, quite obviously. Graduating students aren't quite as interested. They just kind of want to program or something else. So demand's going up, and that certainly would be a great, fun thing to get into. And also after that, I will be studying for CISSP, which is basically a more professional kind of level security type cert, which certifications in this world seem to be very important. For certain projects, they'll want you to have a certain cert or things that it kind of shows what you know, shows what you've gotten into. I find them very important and certainly a good thing to have. So now, Hack Wars. I'm also involved in Hack Wars. This is a LCE event that we put on. I help set up vulnerable virtual machines with certain vulnerabilities, maybe an SQL injection or things of that nature. And it's like a capture the flag event where participants and teams will try to compromise the systems. Once they get in or do something like that, they find something kind of squirrely, they'll get a token, and that'll give them points. It's a great fun event that we do, I help put on, and we try to have 3 or 4 events a year. You don't have to know how to hack either. We certainly encourage anybody to come, and we show any and everybody what we're doing, and kind of raises awareness about security and how to be secure, the things that we do. We try to put on 3 or 4 a year. The next one, I believe, is in October. We're doing one at the Charleston Chamber of Commerce Cyber Conference. Of course, everybody's welcome. So, about Charleston Defense Contracting itself, kind of basically what I like about it from what I've experienced in my few years. So Charleston in general, Charleston's always been home to me. I certainly like Charleston. The beach, great restaurants, seems to be a great place to live. And this kind of work is certainly very prevalent in Charleston. And any kind of computing work in general. I think even Mayor O'Reilly has dubbed it Silicon Harbor. So that's certainly alluding to all the different tech interests we have in the community here. Job security, now, the point I want to make with that is sometimes, depending on the project, you need certain security clearances, basically. And with certain experience and your ability to get certain clearances, certainly makes the pool of potential applicants a lot smaller. Finding jobs certainly easier to have all those qualifications. And interesting topics. A lot of the different development work and things that I've worked on have been very interesting. A lot of things are sometimes military related, so you're doing things with a big impact on, sometimes with different, troops, aircraft, different things like that. And what what you're doing is definitely going to certainly have a big impact. And diverse opportunities. As you've seen, I went from testing, integration, system administration, coding. So there's really a lot of opportunities to do all kinds of different computing work through contracting. Most of mine has been, of course, with just development type stuff with web applications or web services and things of that nature. And with contracts, you never have to do the same thing for very long. I'm with the same company, and it's great, and I get to move on to all kinds of different things all the time, whole new topics and things of that nature. And when you, a lot of times the teams are pretty small, so your impact is great. I was reading that one of the the number one reason people left a company like Google is because they felt very small. They felt like they didn't really have a big impact on what they were doing. And of course, in this world, you definitely have a very big impact. And next one, any questions? Right. Well, hopefully you guys are.
I got one.
Well, sure.
What would you say your perception of the industry was before you got your internship? And how has it changed from going through the internship?
Sure. Well, I really didn't have a very good perception. I really didn't have much knowledge about the industry at all before my internship. I just kind of knew those things were going on. I didn't really also know that it was such a prevalent industry in the Charleston area either, which is great because Charleston's been home to me, and so being able to find great work here was a good opportunity. But after the internship, I certainly, like I was saying, know that it is a prevalent industry in Charleston. Lots of great work. I know there's lots of different defense contract companies I didn't know about before I started.
Do you think you would have been where you were today if you didn't take that leap of faith and do that internship that summer?
Probably not. I know that, like I said, that certainly got my foot in the door in the industry. I guess I did great work. They liked me and I liked them. So I certainly stayed in the industry. It's certainly interesting. So I'm not exactly sure what I'd be doing. I might not have been in Charleston.
Anybody else?
Cool. Well, thank you guys.